Okay, so here is chapter 1, pre-quiz part 1. So we're going to go ahead and work through this. So you should already been doing this, so it's going over it just in case you have any questions on anything. Okay, the first one we're just finding the solution set. So here we just FOIL out, distribute that 2. We got 8x plus 16 minus 4 equals 8x minus 5. We can combine. We got 8x plus 14 equals negative 5, 8x. Then we can add 5 to both sides, so we get 8x equals 8x. Add 5, that should be 12. So that'd be 17 plus 17. Now, try to not get confused just because these are both 8x's, right? So we move stuff to the other side by subtracting or doing the opposite. The only time we want to divide is if there's only one x here, then I would divide by 8, but I don't want to divide by 8 because I actually want to move all that x, the 8x over. So I'm going to subtract 8x on both sides. So then I get 0 equals 17. So 0 equals 17, that's not a true statement because I'm looking for a solution set. A solution set is just what are the numbers that x can be that make it the statement true. Well, here 0 equals 17, that's a contradiction. So I'm not going to have any numbers for x. So there is going to be no solutions for it. So it's a contradiction because that's not a true statement. Okay, number 2, you solve it the same way. So go ahead and you can distribute this and then solve for v. So we have negative 3v minus 12 plus 7v. Now I can take down the parentheses, plus 2 equals 12v plus 5. Now I can combine like terms. So I have 4v minus 12 plus 2 is minus 10 equals 12v plus 5. Again, I don't divide by 4. I move the v over by subtracting it. So I have negative 10 equals 8v plus 5, subtract 5, so minus 15 equals 8v divided by 8 divided by 8. So v is equal to negative 15 over 8. So there's your final answer, and that would be, if we're looking at like from A back here, that'd be a conditional statement. V can only be negative 15 over 8. Okay, solving the equation, we're just rewriting the equation, getting t by itself. So here we are multiplying by 3/5. So how do we get rid of multiplying by 3/5? Well, that is dividing by 3/5. And when we divide by 3/5, we're actually multiplying by the reciprocal. So if I multiply both sides by 5 over 3, the 5's would cancel and the 3's would cancel. And then I would have to do that to the s too. So 5/3 s. And I can just put s right on top with the 5. That is a 5. Equals gt squared. How do I get rid of multiplying by g? Well, I divide by g. And again, when I divide by g, that means I'm multiplying by 1 over g. So g is just going to go on the bottom with the 3. So I have t squared equals 5s over 3g. Then how do I get rid of squared? Well, I square root. And when I square root, I have a positive and negative answer. So t equals plus or minus the root of the top, 5s, over the root of the bottom, which is 3g. And then I need to rationalize, multiplying by square root 3g on bottom, because I need a pair. That's where square root works, right? I need a pair, so now I do have a pair of 3's and a pair of g's, so I can take out a 3 and a g on bottom. And on top, I have the square root, plus or minus 5. 5 times 3, I can multiply that. 5 times 3 is 15. So then I have square root, plus or minus the square root of 15 sg all over 3g. So that's what my t is equal to. Right there. Okay, moving on. Operations of complex numbers. Operations, add, subtract, multiply, divide. So here we're going to multiply. Make sure you pay attention what's happening in between. If there is nothing, no adding or subtracting, so we just FOIL. 4 times 5 is 20. 4 times negative 7i is negative 28i. 2i times 5i, that is a positive 10i. And 2i times negative 7i is a negative 14i squared. I squared is basically just going to change that negative 14 to positive. So you have positive 14. And then you have 20 over here. Well, that comes to 34. So 34. And then negative 28i plus 10i would be negative 18i. And I cannot combine those because that has an I in it and 34 does not. So you got to stop there. All right, now let's do division. So when I'm dividing with complex numbers, it's the same as with the radicals. We got to multiply the top and bottom by the conjugate. So 3 plus 2i on top and on bottom. So that means we're going to have to FOIL. All right, so we're going to have to FOIL the top and FOIL the bottom. Well, the bottoms are conjugate, so I'll have to multiply as first times first, which is 9, and last times last, which is a negative 2i, times a positive 2i, which is a negative 4i squared. And that I squared is going to just change that, change that sign to a positive 4. So, and then I have 9 plus 4, which is 13. So I'm going to have 13 on bottom on my finished fraction there. Okay, now the top, I have 2 times 3, which is 6. I have 2 times 2i, which is a 4i. I have a negative I times 3, which is a negative 3i. And then I have a negative I times a 2i. That's a negative 2i squared. I squared is going to change that to a positive 2. So I have 6 plus a positive 2, and then 4i minus 3i. Well, that leaves me with 1i. So plus I. So I have 6 plus 2, which I can solve, which is 8. So I have 8 and then plus I. So that's my final answer. I can't reduce any of these. I could write as 2 fractions if you want to. 8 over 13 plus I over 13 just to see if you can reduce it. But I can't, so any of these two would be equivalent there. All right, now when you're asked to simplify, you just want to break them down. Keep breaking stuff down until you can get to the lowest terms possible. So here, if you wanted to, you could start breaking it down in 2 fractions, kind of like I did on the other one, or you can start with breaking down the root. That'd be 9 and 2, and the square root of 9 is 3. So I have a pair of 3, so I can pull out a 3. Also, it has a negative in here. Since that negative is in there, that means I can pull out an I. And this 2 remains. It doesn't have a pair, so it stays underneath the root. And then I have over 27. I figure the best way to do this is to write this as 2 fractions. Because when you have 2 fractions, then you get to see if you can actually reduce anything. Now, I can't reduce anything inside the root and outside the root. So I can never reduce something that's inside a root and outside a root. Okay, they both have to be on the outside. So now I can go ahead and I can reduce this negative 15 over 27 by 3. So I get a negative 5 over, like 3 would be 9. And then here I can cancel out 3. I can reduce it by 3. So I get I root 2 over 9. And now since I have a common denominator, if you want to put it back into 1 fraction, you can. You don't have to, but you can. So any of these two would also work as your final answer. Okay, I'm asked to simplify here, but look what's happening in here, right? There's a subtraction sign. Okay, just because you have 2 parentheses doesn't mean multiplication. I'm actually subtracting this whole binomial. So that means I'm subtracting a negative 12 and I'm subtracting a negative 30. So what is 30i? So what that means is I'm actually going to be adding 12 and I'm going to be adding a 30i to this binomial. So combine like terms. What's 7 plus 12? Well, that's 19. What's, oh, I better delete that so I can see. Oh, that's a negative 18i. Okay, so then I have negative 18i plus 30i. Well, that's a 12i. So there, done. So this application problem is a little bit easier than the one we dealt with in class, but Lisa deposits some money. Well, you don't know what that money is, so let that be a variable. Let it be x. So she invests some money at 1.5%. So we want to find out what what money are we going to invest at 1.5%? That's our question. And then what money then with twice as much, well, that's twice as much as she just invested, so isn't that 2 times x? So then we want to find out, okay, twice as much at 3.5. So we want to answer those questions at the end. So we want to find the amount deposited at each rate if we make a total interest income of $25.60. So interest is equal to simple interest, the principal times the rate as a decimal times time in years. Well, since they don't give us our time in years, we can assume that, oh well, it's just talking about total annual. So annual is 1 year, so time is 1. So in our principal, we don't know, that's why it's x. And then our rate is 2 different ones. So that means we're really going to have 2 different equations, but our total interest is I. So really, we're going to add these two principal, rate, and times, because we have 2 rates, and we're investing 2 different principals for 1 year, and it's going to give our total interest of $25.60. So we can enter our principals at x at 0.015% times 1. So we can multiply those, and then plus the second principal rate, principal times our rate, which is 0.035 for 1 year. So then we can multiply these, and we can add them together. I'm going to have some more room here. So we have 2560 equals 0.015x plus 0.07x. Now we can add those x together. We get 0.085x equals 2560. You can divide by a 0.085, because here I'm trying to get x by itself, so I don't want to subtract it. I want to divide because I want to get x by itself. And we get $30,117.65. Okay, so that may not make sense, but you're thinking about making $2,500 in simple interest is quite a lot of money for 1 year, so you're going to have to invest a lot into that. And then, so that's our x, right? So that's how much she's investing, so we can put that here. She's investing, our x is now $30,117.65. $30,117.65 at 1.5%, and then 2 times that would be how much she invests in the other one, the 3.5. So let's go ahead and change that. That would be $60,235.29. All right, the antifreeze problem. We want to pay attention to this and make sure we do a lot of these. So it asks how many gallons, well, how many, so that's the question, right? Of gallons, so that's be our variable, of 50% solution. So that's 0.0, or actually 0.50, right? X. And we're going to be most mixed with, well, that's addition, so I'm going to add 50 gallons of 10%. So that's 0.1 times 50 gallons. And that's going to give us a total of 40% mixture. So that's 0.4 of what, though? What gallons am I mixing? Well, I'm mixing X gallons and 50 gallons. And I'm adding them, right? So that'd be X plus, change color to red, X plus 50. Okay, so now I can distribute that 0.4, so I get 0.4x plus 20 is equal to 5 plus 0.5x. Now I can move my 0.4x to one side, so I get subtract 0.4x minus 0.5x, that would be a 0.1x. And then move the 5 over on this side, so we get equals 15. Divide by 0.1, divide by 0.1. So x is equal to 150 gallons. So it's going to take us 150 gallons of 50% solution to be mixed with to be mixed with 50 gallons of 10% in order to make a 40% solution. So that kind of seems right because there is 50 gallons of 10%, and I want to make 40%, so I need to move up that 10%. I need more, right? So that means I'm going to need more gallons than 50. All right, solving quadratic equations here, since we have just ax squared plus c equals 0, all we have to do is just move over that c, and then if we have an a, then we divide by a, and then we can just square root both sides. So here we can just move over the 20, or negative 20 to positive 20 now, square root both sides, reduce that to 4 and 5. Square root of 4 is 2, so 2 root 5. Put a plus and minus in front because we have two answers. So t equals plus or minus root 5. Here on this one, it says solve by quadratic equation, so you can really do anything. You can do CAB, you could do quadratic formula, or you can do complete and square. If you do CAB or you do quadratic formula, this needs to be set equal to 0, right? So make sure you move over that 22 first. I'm going to do complete and square because it's a little bit harder. So my c is already moved over, but my a is 2, so I need to divide everything by 2, both sides. So I get x squared plus 4x equals 11. Now I can move a spot for my new c. So I'm going to complete the square. I'm going to take my b, do some side work over here, take my b and divide it by 2 and then square it, and that's going to be my new c. So that's 4, so I get x squared plus 4x plus 4, and I got to add it to both sides, right? So that's going to be 15 over here. Now I can factor this, and it always factors to your b over 2. My b over 2 would be 2. So it's going to be x plus my b over 2, which is 2, quantity squared. Okay, so x plus 2 quantity squared equals 15. How to get rid of square root or squared? You square root both sides, put a plus and minus in front of it. Square root 15 breaks down to 5 and 3, so those are both prime, so you can't break that down any further. Plus 2, minus 2 on both sides, so you get x equals a minus 2, because I'm subtracting 2 from both sides, minus 2 plus or minus root 15, so there's two answers there. The power of I, so this is the way I think the best thing to do. I have 31 i's, right? A total of 31 i's. Well, how many I squareds do I have? Well, I squared, when I raise powers to powers, right, I multiply, so I need to get a total of 31. Well, when I take 2 times 15, I get 30, and then I need an extra I. Well, I squared equals negative 1, so this would be negative 1 times itself 15 times, and then multiplied that by an I. Well, 15 negative 1s, that's a negative 1. And then times by I would be a negative I. So I to the 31st would be a negative I. All right, I to the 16th, well, that's I squared raised to the 8, right? 2 times 8 would be 16, and negative 1 times itself 8 times, an even amount of times is always positive. So I to the 16th would be a positive 1. All right, so that's it. You can go back through this as many times as you want. Still ask questions.